Welcome to discussion 5. In today's discussion, we'll be talking about the second half of 2.3 on evaluating limits algebraically. In this video, we're going to do some examples where we evaluate limits that have absolute values. So I want to begin by recalling that when we have the absolute value of some stuff, when we get rid of the absolute value, one of two things can happen. So I'm going to write this as a piecewise function. If the stuff inside the absolute value is greater than or equal to 0, then I can just get rid of the absolute value and I'll just get the stuff that's inside. But if the stuff inside of the absolute value is less than 0, if it's negative, then when I get rid of the absolute value, first I would just have the stuff. But right now that would be negative. I need to make it non-negative by putting another negative in front of it. So we're going to use this idea to rewrite absolute values as piecewise functions. All right, so I want to have you try a couple of worksheet problems. So first, question 7f, limit as x approaches 0 of x over the absolute value of x. And then from worksheet 3, problems 1, part A and part B, but just part A and part B. So pause the video for 5 minutes to try these. 4, 3, 2, 1, pause it and try those for 5 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried these for about 5 minutes. Let's start to talk about these together. So for 7f, first thing I'll try is plugging in. That's often my first step. And that gives me 0 over 0, which is indeterminate. So I am going to simplify. So we want to simplify this. Okay, so I'm going to use that idea that we reviewed above to rewrite absolute value of x as a piecewise function. So I need to think about, well, when is the inside going to be non-negative? That happens if x is greater than or equal to 0. In that case, I can just get rid of the absolute value and write x. If the inside is negative, which happens if x is less than 0, then I can't just get rid of the absolute value and write x, because that would be a negative value. I need to put a negative in front of it to make sure it's a non-negative value. Okay, so I want to visualize this now in a couple of ways. So I'm going to draw a number line. I'm going to put 0 on the number line. That's sort of the place where this, where the x, the stuff inside, switches sign. So my absolute value of x, when I plug in things that are bigger than 0, it ends up just being x. But when I plug in values that are less than 0, it ends up being this bottom piece. The absolute value of x ends up being negative x. Okay, and let's use this to now form the graph. If I draw on some xy axes, what we're saying is the absolute value of x should look like x, so the graph of y equals x, which is a line going through the origin, and the slope is 1, but only where x is greater than or equal to 0. That means I'm only going to draw this part of that line, just the part of it where x is greater than or equal to 0. When x is less than 0, I'm going to draw y equals a negative x. When x is less than 0. So that's going to be a line still through the origin, but the slope is negative 1. That looks like this. And that is the absolute value graph that you may be used to seeing. Okay, so that matches up with the piecewise definition. Alrighty, let's use one-sided limits now. We are going to use some one-sided limits. And the reason why is since x is getting close to 0 here, and as it happens that our absolute value can be, sometimes it's going to be x, and sometimes it's going to be negative x, depending on which side I'm approaching 0 from. Alright, so let's do the limit from the right, and then we'll do the limit from the left. So from the right, we get the limit as x approaches 0 with the plus sign, x over absolute value of x, which equals the limit as x approaches 0 from the right. I'll keep x on the top. And on the bottom, because x is approaching 0 from the right, that means x is a little bigger than 0. And if x is bigger than 0, that means we're using the top part of this piecewise function. The absolute value of x is just x, because the stuff inside is positive. Okay, and that simplifies nicely. We get the limit as x approaches 0 from the right of 1 and that is just 1. All right, let's do the same thing from the left now. So from the left, we are going to get the limit as x approaches 0 from the left of x over the absolute value of x. So the limit as x approaches 0 from the left of x over something. And because we're approaching 0 from the left, that means x is a little bit less than 0. And that means we're going to use the bottom piece for the absolute value function. The absolute value is going to be negative x. Because x is less than 0, the inside of the absolute value is negative. So I need to put a negative in front of it to make it non-negative. All right, now I can simplify. And I get the limit as x approaches 0 from the left of -1 after canceling. And that's just -1. Okay, so my one-sided limits are different. So I get to say, since the one-sided limits are different, our limit, the limit as x approaches 0 of x over absolute value of x, D and E, it does not exist. All right, that's our answer. Let's move on to question 1, part A. All right, the first step is I want to plug in. If I plug in 5, I'll get an absolute value of 5 minus 4 on the top. On the bottom, we get absolute value of 3 minus 5 minus 1. So the numerator is 1. The denominator is going to be 2 minus 1. So overall, this is just 1. And there's no issue there, so that means that is my answer. Okay, so 1A was a quicker one. Let's do 1 part B. Let's start it off by plugging in again. If I plug in 4 this time, I'm going to get 0 on the top. On the bottom, absolute value of 3 minus 4, that's going to be 1, and then minus 1. So we get 0 over 0, which is indeterminate. But we know to handle that, we're going to have to simplify. And we've seen now how to handle these absolute values in terms of piecewise functions. So look, this time we have 2 absolute values. Let's write both of them as piecewise functions. So let's do it for absolute value of x minus 4, that as a piecewise function. And then we'll do it for the absolute value of 3 minus x, and write that as a piecewise function. So for x minus 4, let's think about what would happen, what would need to happen for the inside to be non-negative. X would have to be greater than or equal to 4. And that makes the inside non-negative, so then I can just get rid of the absolute values. That's just going to be x minus 4. If x is less than 4, then the inside of the absolute value is negative. So when I get rid of the absolute value, I need to put another negative in front of that whole thing to make it non-negative. Let's do the same type of thing for absolute value of 3 minus x. Well, what would make the inside non-negative? This one's going to be non-negative if x is less than or equal to 3. And that makes the inside non-negative, so I can just get rid of the absolute values and write 3 minus x. If, however, x is greater than 3, then the inside of my absolute value is negative. So when I get rid of the absolute value, right now this is negative. I need to make it non-negative, so I stick a negative in front of that whole thing. Okay, so I'm going to organize my work a little bit into a number line, like I had drawn above. But this time for my number line, I'm going to put tick marks at the places where my absolute values switch signs. So that happens at 3, and that happens at 4. And then I'm going to write a row for each absolute value. Absolute value of x minus 4, and the absolute value of 3 minus x. I'll kind of separate out columns here and make a row here. All right, so for the first absolute value of x minus 4, when x is greater than or equal to 4, so on the right-hand side of 4, I'm going to use this top piece. I get to use x minus 4. But when I'm on the left-hand side of 4, I'm smaller than 4. And there I got to use the bottom piece. So negative x minus 4. Even here as well, negative x minus 4. Let's do the same thing for the absolute value of 3 minus x. When x is less than or equal to 3, that's the left side of 3, I get to use 3 minus x. But on the right side of 3, I have to use negative 3 minus x. Same thing here, negative 3 minus x. So now we are going to be ready to take some one-sided limits. So take some one-sided limits. So let's take the limit from the right and the limit from the left. So from the right, let's first write it. The limit as x approaches 4 with little plus sign, absolute value of x minus 4 over absolute value of 3 minus x minus 1. Okay, so this is going to be equal to the limit as x approaches 4 from the right. And now let's think about how we're going to simplify the absolute value on the top and on the bottom as x approaches 4 from the right. So going back to my number line, we are approaching 4 from the right, which means we're getting really, really close to 4, but we're on the right side of it, so we're somewhere here. So the absolute value of x minus 4 is just x minus 4 there. So let's write that on the top. So on the top of this fraction, we get x minus 4. Now let's do the absolute value on the bottom. So going back to this number line, remember we're approaching 4 from the right, so we're somewhere over here on this side of 4, getting super, super close to it. And the absolute value of 3 minus x is negative, and then 3 minus x there. So going back to the problem, we'll write negative parentheses 3 minus x for that one on the bottom, and then minus 1. And now the absolute values are gone, so we can simplify. The limit as x approaches 4 from the right, x minus 4 on the top. When I distribute the negative on the bottom and combine like terms, we're going to get x minus 4. So this gives us a perfect cancellation, and we will just end up with 1. All right, let's do the limit from the left. So from the left now, all right, so we need the limit as x approaches 4 from the left of my absolute value of x minus 4 over absolute value of 3 minus x minus 1. This is going to be the limit as x approaches 4 from the left. So let's go back to the number line. So now we are going to be approaching 4 from the left-hand side. That means we're getting super, super close to 4, but from the left, which means we're somewhere over here. We're in this middle interval between 3 and 4. Okay, so the absolute value of x minus 4 will be negative parentheses x minus 4. And the absolute value of 3 minus x will be this negative parentheses 3 minus x. So let's use those. So back to the problem. Both of these now have a negative in front of them. Negative parentheses x minus 4 over negative parentheses 3 minus x minus 1. Now I simplify. Limit as x approaches 4 from the left. Let's keep that negative factored out on the top, because we know from the previous part, the bottom just became x minus 4. Now I get the x minus 4's cancel, which just gives me negative 1. So the limit from the right is 1. The limit from the left is negative 1. Since those are different, since the one-sided limits are different, since the one-sided limbs are different, the limit, our original limit as x approaches 4 of absolute value of x minus 4 over absolute value of 3 minus x minus 1 does not exist. D and E. And that is our answer.